Hi, in this video we're going to explore the Rhino.geometry.transform class or struct, which is under the Rhino.geometry namespace, and this will be how we can handle any transformation that we wish for any type of geometry that we need or we have. If we hit down, we can find the transform struct, and a transform struct usually returns, its methods usually return a matrix with a transformation matrix, and this transformation matrix does exactly the transformation that we need. So a mirror method creates a mirror transformation matrix, and this can be applied to our object. We can multiply two transformation, that means multiplying two matrices and getting the result. We can rotate, we can scale, we can translate, and as we've seen before, some geometries don't have a translation and rotation and scale methods, and in order to do these transformations to those geometries, we need to use the transform struct. And to do so, in this file I've added a box and a point, and let's try mirroring this box using a vector 3D that has this point as an origin and it's directed to the z-axis. In order to do so, we can say that box.transform, and then we open two brackets and transform dot mirror, and inside mirror we'll add our point and a vector 3D dot z-axis. So the result of this very method should give us a box that is located around this space, right? But if we run, we don't have any error, and yet we don't have the mirrored box. In order to show the mirrored box, we need to add that a equals box, and this will give us the box in the location that's needed. Actually, we're not going to use the z-axis, we have to use the y-axis, and this will, or the x-axis maybe, I'm not sure. Yes, so the x-axis, I'm sorry for that, will give us a box that is located exactly here. So what if we want to move this box to the point 550? In this case, we will type transform.translation, and here we should add a vector or three doubles, and that will be 5, 5, and 0. And if we run our script, we will have the box moved to the certain place. If we make it like 5, 5, 5, then the box will move in the z direction, and so on. In order to scale our object, we can just type transform.scale, and inside we'll add a point anchor, which is maybe the box's center point, and a double scale factor. In order to get the box's center point, we just type box.center. So box.center, and we'll add a scale factor, which is, let's say, 2. If we run this, then the box will be doubled in scale. If we make it all 0.5, it will be smaller. If we change the center point, let's make it the origin. So point 3D dot origin will be will give us a different transformation. Actually, what if we want to make the center point exactly on the center of the lower face of the box? In order to do so, we can say box dot center minus the minus a new point 3D, which or minus minus a new point 3D, which will have a 0 x 0 y, but the z should be the height of this box minus divided by 2. So how can we get the height of this box? Let's try and see the method. So if we get box dot, maybe there is dot z, and this will give us the height of the box. And if we divide it by 2, and let's add this between two brackets, in this case, oh, there is a problem. Okay, the z is an interval actually, so we have to say dot z dot max, so we get the highest. So because the box dot z gives us an interval from the lowest point to the highest point, and in order to get the highest number, we need to type box dot z dot max. And if this doesn't work, let me check why for a second. All right, so pure mathematical problem, and here if you want to get the point at the end of this box, at the lowest surface of this box or lowest face of this box, we need to add a new point here. This new point will have the same x and y location of the origin, so we can say box dot origin new point 3D at box dot origin, which is not showing, or center, I mean, not origin, dot x, and box dot center dot y, and we need to type the z. So the z here, let's make it a double, and double z will be equal to box dot z dot min, which is the minimum value of the z. And if we run this here and just add a z here, in this case again the problem point 3D could not be found. Here box dot z dot minimum, and here box dot x dot center. Yeah, here is a point 3D, I'm sorry. And so this will be our origin here. So we use the box's center x coordinate, the box center y coordinate, and the z will be the box's lower faces center, which will be here. Okay, so what else can we do? We did a scaling, we did moving. We can rotate this box. Let's try rotating this box here, and now we will type dot rotate, and let's see what's going. I'm sorry, dot rotation. And here we need a sine angle, a cosine angle, a vector, 3D rotation axis, and a rotation center. Or actually we can do it with some other overloads, which are an angle, a radiance angle, and a center. So again, our center will be a new point 3D or we can just take the center of the box, so box.center, and that will be our point, and here we'll add an angle that will control from the inputs. So if we run this and we add here an angle that is a double type, that is of a double type, in this case we can add it from 0 to 6.22, and here we go. There is a typo in our code which is closing this bracket, and here we go. So if we start playing with this number slider, it will rotate 360 degrees. Let's check what other transformation that we can do. We say we can clone, we can make it equal to another transform. We can transpose, which is flipping the rows and columns of a matrix. Okay, I think that's what we need actually in the transformation, or in the transform. Struct, which we've seen in this video, we learned how to move or translate an object. We've learned how to scale an object, how to rotate it, and that's it. Thank you for watching, and before ending this video I want to say that we can add any geometry that we want, and if we added a curve here instead of the box and we set this curve and we added it here but with the type hint that is curve, we can rotate this curve as well. But yeah, we don't have this a center, so we need to add a certain point. So if this was our point here and we move this point to almost the center of the shape, we can be rotating it. So we can do these transformations to any type of objects. Thank you for watching again.